Good morning, everyone, and welcome. My name is Sudheer Matta. I'm the VP of Products here at Juniper Mist, AI-driven Enterprise. Literally, that is our name. And it is my absolute honor and pleasure to be here. We are stoked to be part of AI Field Day. And thank you, Stephen and the Tech Field Day team for launching this. This is near and dear to our heart. What you're going to hear today is actually, candidly, a lot of the same stuff we've told you over the last 4 years. And we're proud of that. In fact, some of these slides we presented 3 years ago, and we're super proud of that because we had a clear vision and truly a conviction of purpose that we can bring AI to networking and bring them to deliver business outcomes. And so a lot of what you're going to hear from Bob, Jisheng, myself, and others today is how is AI impacting our customers? Lots and lots of customer stories there today. But without further ado, let me introduce truly our heart, our soul, and our visionary. And day one, he drew this on the whiteboard and led us to being the leader in the enterprise networking space. Bob Friday, the CTO, co-founder of Mist, and now the CTO of Juniper's AI-driven Enterprise. And right after him, I'll introduce Jisheng as well. Bob, if you want to say quick hello.
Hello, Sudheer. Hello, everyone. Thank you. It's great to be back. And as Sudheer says, this is one of the passions and one of my passions. So it's just great to be here.
Yeah. And let me introduce very quickly. Thank you, Bob. Very quickly, our head of data science, Jisheng Wang. Jisheng is amazing. For a data scientist and a team of data scientists, a big team of data scientists behind him. They are intently focused on customer outcomes. And so that's what we're going to talk a lot about today. But Jisheng, a quick hello from you.
Good morning, everyone. And really glad to be here to share some of the real world AI experience we have.
Awesome. Without further ado, thank you, Bob and Jisheng. Let's dive into it. This is a familiar slide for most of the Tech Field Day audience, and we've been at this for quite some time. Bob, I'm going to turn over this to you.
Yeah, I mean, for some of those who know us, right, when Sudheer and I started in this back in 2014, one of those inspirations was really Watson playing Jeopardy, right? That's when we kind of saw that this AI stuff was becoming real and could do useful stuff. And that's when we kind of got to, if they can build something that can play championship level Jeopardy, we should be able to build something that can really answer questions and manage networks on par with network domain experts. And that journey really started with data, right? And that's one of the reasons why we decided to build our own access point, because the questions we were trying to answer were the hard ones, right? Why is someone not able to connect? Why is someone having a poor internet experience? And we wanted to make sure we could actually get the data to answer that question. So that's where the journey starts. As Sudheer mentioned, this slide has been up here for 3 or 4 years now. And the reason it hasn't changed is because the mission has not changed. What has changed is that our expanse of data has changed, right? As we join the Juniper team, we're starting to expand our data ingestion across the whole enterprise portfolio, right? We're ingesting data from APs, switches, routers, even the SDK, the client itself. We're starting to bring that client's view of the network back into Marvis. And what does that really allow us to do? That really allows Marvis to answer more questions with more granularity. When we start to bring that router into Marvis, that lets us start to answer questions about why is the application having user. So that is where the journey has started. The journey has not changed. The journey is just getting broader and deeper as we go along. When we move on to the AI primitives, right, I think what you first saw out of us was our SOE metrics, right? And what was unique about that was compared to what I did 20 years ago at Aerospace, right, where we're trying to help enterprise manage these access points, is really what's changed now. It's really all about the user. 20 years ago, we were not pulling data back about the user. We're pulling data back about the access point. Now what's changed is we are actually pulling back every user minute from the access points view of the world, right? And so that data there is being aggregated over time and space from AP, floor, site, building in over 5, 10, 20-minute weekly average. And what that primitive really is set up for is really to allow the data science, like mutual information, now to extract insights out of that data. Now, interestingly, what turns out is that once you get the data in the format to apply data science, it's actually a format that actually an IT person, right? The same format that Marvis needs to do with that data is really the same format that your average IT person appreciates. And that's what we learned when we actually did it, is once they had that visibility, once they had that data in the cloud, for the first time, they didn't have to go back to their access points of their network to get the data. The data was at their fingertip. You know, the IT departments now had the data they needed to help answer the questions, even if Marvis didn't have it. The other key part is data science. This is changing the game here. We know what data science has done in all the other things, right? Whether it's driving cars, doing diagnosis in the medical world. In our networking world, these same algorithms are starting to actually let us get to very low false positive anomaly detection. So this data science and this deep learning stuff is making a difference. It's making a difference inside of our industry right now. And then as you can kind of see, we'll get into the virtual assistant and the conversational interface. And that's really about, you know, whether it's a person or a virtual AI assistant, you have to learn to trust this assistant, right? Just as you would a new hire employee, right? And that's why the conversational interface is important, because it's really what allows you to extract data from the network, makes it easier for you to get access to that data quicker. And that's what we're starting to see in our support. You know, Marvis, even if it doesn't have the correct answer, it gets you to the data quicker that you need to get your access. It gives you the interface and lets you actually get to learn to trust your assistant. And it actually provides the interface that allows you to give the assistant feedback, you know, in terms of making corrections, right? Just like you would a person. Yeah, when Marvis makes a mistake, you let Marvis know, and it will not make that mistake again. And so, and this all leads to really the beginnings of proactive, right? This is the ultimate dream where we want to get to, where you can actually start trusting Marvis to take over some of the more mundane actions inside of your network. You know, whether it's finding a bad cable or proactively finding that RMA, these are things that you do not need your IT time spending hours and hours on.
Quick question on this. I think this is a very cool picture, and you said that like 3 or 4 years ago, you were able to predict many of these things that you have been doing. So has there been any surprises then related to data? Anything that you couldn't predict during this journey?
Yeah, I would say during the journey, to be honest, you know, when I rate, you know, if you look at the Watson, that was the same thing. It was about a 4 or 5 year Watson to play championship level Jeopardy. So far, the journey, we're probably up to 60, 70% level championship level. You know, every ticket that comes into Mist right now, we basically let Marvis try to answer it first. You know, so far, I think we're on track where, you know, compared to what I saw Watson do, we're on track to get to championship level Jeopardy in the next year or two, right? So far, I would say the only surprise, if I've seen any surprises, you know, to be honest, I haven't seen. I mean, I think we're just, you know, it's a long journey, right? It's a multi-year journey. And that's why you keep seeing the same slide, right? It's not something you're going to get done in a year.
Katie, maybe if I could chime in, one surprise probably should not have been a surprise for us is the impact AI had. If you asked me to guess, you know, let's take a university. We've deployed in a university about 7,000 APs, and if you asked me, hey, Sudheer, could you guess what percentage of their frontline tickets AI and your self-driving can take down? You know, candidly, I probably would have said maybe 20%, 30%, whatever. Consistently across all verticals, truly, we're seeing when we deploy this AI-driven system, we're seeing north of 60, 70% reduction in tickets coming into help desk. Not even, you know, tickets on how long it takes to troubleshoot that, you know, a ticket that came in. It's obviously a positive, you know, turnout of this, but that impact and the consistency of it across verticals says that a lot of our customers suffer from pretty much the same problems, right? You know, the network happens to you, you know, because iOS did an update or Android did an update, and you think you run the network. You really don't, because the devices have the brain of their own, right? And so it's that learning and the impact we're having on customers. It is incredible. The stats are, and so that's something, a positive surprise, I'd say.
I would say the other surprise, Katie, there's some people 3 or 4 years ago who didn't believe in AI. they're now starting to see the value of it.
Can you give us a little bit more context on this 67% number and the reduction of calls into the help desk? One of the things as a HR manager or people manager is that you're looking at the skill needed to operate that second, third level and filter out the, those first two levels of calls. It's a completely different skill set from a first level tech to a third level tech. Are third level techs still getting first and second level calls, meaning that I'm spinning my tires or inefficiently using those resources?
Right. So Keith, there I put them in three things. When we put a Mist Juniper network in, there are three things that are unequivocally happening. Number one is, and I'll talk about specifically to your question, how the hell do we get that kind of efficiency in just tickets coming in? That's number one. Number two, so first is we are reducing tickets coming in. Number two, we're actually dramatically cutting the mean time to repair on tickets that do come in, right? One customer, they're deploying our network in 130 countries. Their average support ticket resolution time went from 48 hours per ticket, that's their average, to 2 hours per ticket as an average. That's sort of a 96% drop. So first is fewer tickets. Second is faster time to resolution. And really, I think, and then the third is, one of the things that is not necessarily AI, but it's probably part of the system here is one of the service providers, one of the top 4 service providers in the US, they did a deployment with us about 12,000 and now up to 31,000 APs. In the first 12,000 APs, they found that they had a 50x acceleration in how fast they could deploy. Nothing to do with AI, Keith, but they used to deploy one store every 2 nights because of controller and image and blah, blah, blah. And they went to 25 stores a night with us and said this is the fastest deployment they've ever done in their retail technology rollout history, right? So those three things. But let me answer your first question. And I know I'm not eating up time on this slide. Jeff is already twitching, saying, hey, man, get off. But it's very important. How do we get fewer tickets, right? What gives? Here's how we believe, and that is why this is so important. We have a system. It's a living, breathing, elastic, scalable, self-driving system that's running in the cloud. And that's why this is so fundamentally different than anybody that took a network management in the cloud and renamed it and suddenly now has AI. Our system, because it's a dynamic baselining it's looking at anomalies, and we are. So if you look at a lot of the problems in the field that are intrinsic to our system, we're fixing them by virtue of learning and anomaly detection and literally real time without IT intervention. Meaning if you have a software process got stuck, if you have a hardware chip got stuck, your beacons are not going out, your multicast is getting dropped, your AP is not transmitting packets to Ethernet or vice versa. All of those types of things we quickly detect, and we're going to go into this section. I attribute fewer tickets to self-driving, and we're going to discuss that throughout the day today. And that's of course we've built a great network, and part of that is that. And then if it's not self-driving, then the ability to proactively find users having problems and get them to a better place. I'm going to show you a demo of that, Keith, that one of our customers, ServiceNow, actually, they taught us a whole new schema of how to get them better, right? So this is the framework, 5 phases, right? Data, AI primitives, algorithms to dynamic baseline and adapt and react, a conversational interface, and self-driving networks.
You talked about reducing the MTTR time. So obviously the AIOps MTTR classicness has 2 parts to it. One is the MTTI, mean time to identification. The other one is the resolution. The identification obviously consists of event correlation, noise reduction, and somehow figuring out based on the incident this happened. Therefore, are you reducing majority of that? Or the second portion of that is MTTR, which is more about runbook automation, self-healing networks, or self-driving network, as you call it, or you do both of that? If so, I'd love to find out about the second portion of that if you really do that.
Andy, there's a full 30-minute conversation on the second portion, self-driving, that's coming up, but we do both of that. Yeah, absolutely, and so we'll speak to that. Great question. Thank you.
Yes, good morning. I do have a question regarding to Marvis. So I'm new to Juniper, so maybe this is a frequently asked question, but so if a customer buys hundreds of devices, is there one Marvis or are there multiple Marvises? And so I'm trying to understand how the AI architecture kind of works, right? Is the device autonomous from an AI perspective, or does it rely on something in the cloud somewhere where Marvis is a single entity controlling all the devices?
Yeah, so I'll take a stab, and Bob, I'll let you chime in as well. But we run Marvis is our AI engine, and we have a conversational interface to it and a natural language processing interface to it. But it is looking at the entire organization. But as Bob's going to speak to this in one slide, it's all about data, and so we're going to lay out into specifically how we are, uniquely per user per minute data, and that data that's coming into Marvis is able to assert the experience of that user. But Marvis is the AI engine that's running, and looking at the entire picture, including it from a user to an AP to a site to a complete organization across, several countries, if that's the case. Bob, anything else you want to add?
I mean, I think the simple answer, Marvis is your single AI ops solution across Juniper Enterprise. And ingest data from every, what question we're trying to answer, we'll ingest data from any source to answer a question.
Okay. So what happens when a server who's connected to the WAN is disconnected from the WAN and can't reach Marvis? How does the isolated network switch then communicate its issues or questions to the end user?
Great question. We actually store a lot of that data, in the some of that data transient in the network systems itself, and the connection gets restored. We upload it. If it's a prolonged outage, yes, you will lose some data, but for the most part, in this day and age, our customers, we don't actually consume a lot of data. We actually have a lot of customers that run on, we have a customer that runs on 512 kilobit lines. That's the entire WAN link to their stores, and we still, provide all of this AI we're talking about. But yes, the Marvis runs in the cloud, and there's some data entropy that is in the device itself. But if it's a prolonged outage, then there is a gap.
Right. Thank
there's
you.
a gap. But interestingly, things like, if an access point gets disconnected from the internet somehow, we've got mechanisms like Bluetooth. We'll have that access point transmits its status via Bluetooth to its neighbor to help get its status back to the cloud. So there's redundancy built into the system trying to overcome internet breaks. If that makes sense.
Yeah. Okay. Thank you.
Okay, I'll do this quickly, Sudheer, so we can move on. So for those who know me, I also make wine in my spare. I make a barrel of wine a year. And so my famous saying is, great wine starts with great grapes. Great AI starts with great data. When we actually started Mist, one of the things that's unique at Mist compared to what I did back in my aerospace days 20 years ago was back then we sent synchronous data back, right? We'd send data back every minute, every 5 minutes or so. This time around, we send both asynchronous data back, synchronous and asynchronous data, right? And that asynchronous data is really the user state. If there's ever a change in the user state, that access point will send that information back to the back end, right? And this is really where the beginnings of the paradigm shift from, I'm not here to help you manage an access point, a router, or a switch. I'm really here at Mist this time around to help you manage the end-to-end client-to-cloud connectivity. And Frederick, to your question, right? Yes, I need to get data back to the cloud. The first step in that mission is to make sure for Marvis to work, I have to have that data back in the cloud. The data cannot be stuck in an APR access point. So that's probably the point of this slide here is really user state, right? The focus here is really understanding the state of the user or the state of that device connected into the network.
Hey, Bob, do Do you have any stats on how much data is coming back to Marvis?
Yeah, so right now every access point looks like a Skype call, depending on exactly how many clients are connected to that access point. It looks like maybe 6 to 10 kbits per second of data continuously coming back to the cloud right now.
Awesome.
Just a clarification. You mentioned 6 to 10 kbits per access point. Is that per day or is that per?
That's continuous.
It's
continuous, like per second.
So Ray, actually, it is right now. We on average we send 2 kilobits per second, 2 to 3 kilobits per second per access point, right? And so if you have 10 access points or 5 access points in a retail store, multiply that linearly, and it's kilobits per second.
All right, thank you.
Yeah. So I don't know Juniper well either from an architecture perspective, but you keep saying the cloud. Is that a public cloud? Like, where does the data, where is it put into its data lake?
Yeah, so we are in the public cloud. Mist runs as a cloud SaaS service. We have clouds around the world, but yes, it is in the public cloud, and we offer the product. So Gina, just so you know, we are basically selling access points, switches, routers, security appliances, all streaming data to our public cloud, and then all of this AI comes out of that data lake that we're building. Make sense? Yeah. Awesome. So let's actually start with what does this data mean, and how does this fundamentally differ from there are vendors that are going to follow us here that's going to say, hey, more data, more accounts, more users, more of everything is all good. Our assertion is it's actually the quality of data. There's a Harvard Business Review article, right? More garbage is not good for AI. It's actually the precision and quality of data that separates us from almost everybody in the industry. So what is the singular?
Sorry, if I can.
Yeah, go ahead.
Sorry, what type of data do you gather? Did you cover that?
So I'm going to show you in just a minute.
Thank you.
Yeah, thank you. What's the singular focus for us when we say data every user every minute? Lisa, I think so. What we're doing is every user, literally every user, every minute, we're gathering data around, was that user minute a good experience minute, or was that a bad experience minute? So every user, every minute. Imagine you connected at your home right now, or our largest customer now has 100,000 access points being deployed, about 80,000 in production right now. And their average client count, simultaneously connected client count, just in that one organization is about 400,000 users, right? 400,000 devices in one organization. And every one of those 400,000 devices on a minute-by-minute basis, we're saying, hey, was your coverage experience good? Was your capacity experience good? Was your throughput experience good? Were you able to connect fine if you were connecting during that minute? So every user, every minute, we're carrying, several hundreds of state vectors into the cloud for that user, and that's foundation on us, in the machine learning models, the features that we can use to classify if that user is having a good or bad experience. It starts with this granularity and quality of data. Lisa, did I answer your question?
Sorry, yes, thank you.
Awesome. Yeah, thank you. Yeah, so that's what we're using. Basically, we're taking every individual user's experience every single minute. Whether IT cares about that user experience or not, we're collecting, collating, and curating it. And this forms the basis of all the AI, right? A lot of other companies use SNMP polling and archaic old stuff. They don't have this kind of every user, every minute data, and that's what sort of separates us. Now, once we have this kind of data, then you go in and say, what primitives can we land such that we can measure are we meeting the user's experience vectors, right? So Bob, I'm going to quickly have you chime in here.
Yeah, so thanks. So when we go back to that primitive drawing, so this is an example where we're starting to expand for Marvis. We're starting to ingest data from switches and routers. So when you look at the switch, we want to do the exact same thing we did on the access point, right? We want to aggregate data up from the user experience. And what this really allows us to do on the switch now is now like the VLAN use case, right? We currently can actually look at HP Cisco switches through LLDP. So we have visibility into those switches. What we have with Juniper now is the ability to actually do something with that data, right? So now Marvis has more granularity. In fact, I get data from switches, so I have more visibility if I'm having a switch problem or a VLAN problem. But with the Juniper switch now, we can also start to take action on that data. So this is kind of an example of where that primitive framework, that same framework that we used on the access point, we're starting to extend it across our switches, across our routers. And then when you get to ginseng, we'll talk about how we're taking those events from the different events and putting them into graph for temporal correlations. So this is the power of the framework, right? We're applying the same framework, and that's why you see the same graph year on year, right? The same graph we've been showing you, the same framework is being applied to switches, routers, and devices also.
Bob, a curiosity question. I get that you're able to measure the network that's under your control, but with the work from home concept now, almost the entire B2B or the business network has moved to the home network now. Are you able to granularly measure even the consumer side of the network?
Yeah, I think what I think you saw, if you've seen the news, right? Juniper just acquired a SD-WAN router company, 128, a software RAN company. Mm-hmm. So I think if you look, the home is a good example. The home is becoming the new micro branch of the enterprise, right? And actually, it's kind of a good example of, where IT now needs complete visibility, right? So AI is becoming even more important, and what we're looking at, what enterprises are starting to do, they're starting to stick enterprise class devices in your home, right? Like when I'm at home right now, it's like, yes, I have to be worried right now whether or not my broadband internet is going to stay up, right? What's going to happen if all of a sudden it goes down, right? Yep. I need SD-WAN at my house, right? I've got my hotspot phone right next to me for emergencies. Ideally, I want my network to take care of that home. So yes, we're starting to work with people around, taking software-defined routers like 128, stick it in the home, and ingest data from that piece of the point of view. So when something goes wrong, they can proactively take care of it. IT wants the same visibility in the house that they had in the office.
Got it. Thank you.
Yeah. And Andy, actually, what we are starting to see, like I'll give you a very simple example. I know all of us have examples like this. We have a hospital that took all of the agents that call insurance companies and get payments and call patients and get payments. They moved all of them out of the hospital, converted that into a caregiving facility, and these people are never coming back, right? They're staying at home collecting insurance payments and stuff like that. So quickly they found out, holy cow, we can't support their experience on Comcast and whatever home broadband and home AP they have. So they're now giving out, Mist APs at home. First, it's an enterprise grade, Wi-Fi device. But most importantly, they're able to now bring Marvis home for all of these users to be able to answer the question, hey, when I join the Zoom call, I'm having this issue. When I'm on Teams calls, my call drops, whatever it is, they're leveraging Marvis to be able to answer that. Enterprise at home is a real thing, and we're seeing massive, as you saw in Jeff's numbers, throughout this experience. Even though corporate deployments have slowed down, our business has actually, far exceeded pre-COVID projections because of this AI at home, enterprise at home movement as well.
Yeah, Sudheer, I get that. Because what happens is, when people were moved from the offices, all the remote locations into going into home, they thought it's temporary, and then it has become permanent now. So every company, large enterprise that I'm speaking with, they realize that, it's a lot cheaper to set them up in the home office. So that becomes their office in the future going into. So that was my reason I asked you a question. Do you have a visibility? But then by providing the equipment, which is a lot cheaper than providing an office space, that's easier to deal with. I get it. Thank you.
Yeah, it's far more supportable. Yeah.
Sudheer, on that though, let's talk about the opposite end of that, which is I don't necessarily want that corporate infrastructure into my home either because of trust or policies that might be put on my home network, and I have more than just corporate information, corporate data riding on that network. I guess two questions. One is, are you finding that those kind of work from home deployments are trying to deploy corporate policy? And then the second is, how do you address that or even coach your clients or customers to address those kinds of issues?
Yeah, in general, I think as the world is moving to sort of zero trust and ZTNA and security, the perimeters, the security perimeters are being shattered. The enterprise is coming home, Tim. Right? I think that's a given. It's happening. For us, what every customer we've spoken to talked about is, how do we get visibility and supportability at the same level, especially like Andy said, if these guys and girls are going to permanently stay home? Just to basically bring this, right? So, there are an incredible number of companies that are continuing to, we all think of work as what all of us go into an office. But there are healthcare institutions, higher ed institutions, robotic, distribution facilities. Our business has gone through the roof. In fact, deployments are accelerating even within the enterprise. I mean, not the traditional corporate enterprise, everywhere else, right? And so one of the things that we found as we jumped into this is there are only two types of users in any network, literally only two types of users. Right? Users that connect on the Wi-Fi network or users that connect on the access switching network. That's it. So we started our journey with the Wi-Fi piece, but now what we've added, this is actually the deployment at the Juniper Global Corporate Headquarters. We've added visibility to the wired network. Why is this critical? With IoT, with sensors, with everything that is coming at us, our customers said, hey guys, we love the Wi-Fi visibility you brought. Can you bring the same veracity and efficacy of data to the wired networks? So what we did is, literally, we launched this in Juniper about 9 months ago now. And this number, the successful connects number, was 24% on our global corporate headquarters. And IT said, no chance in hell. You're telling me 76% of the time, devices that are trying to connect on my wired network are not able to connect? We said, well, data doesn't lie. So turns out they found 3 types of devices on the wired network. Number one, devices that never belonged on the network. So they were able to quickly isolate, identify, remove them. Number 2, devices that were previously working, but because someone pushed some config change and suddenly that port got blocked, but a thermostat doesn't open a support ticket, an IoT device doesn't have, doesn't scream at us. So that device has just been disconnected and languishing, right?
I have a question. Sorry.
Yeah, go ahead.
I was thinking, so you talk about the APs. Do you connect to other APs, like other vendors? Do you have a centralized management for them as well?
Yeah, so Alyssa, great question. So today, what Marvis does is we do take data from third-party systems, such as switches that are not connected to Mist. We actually learn a lot of the switching parameters via the APs using LLDP. We do a lot of AI, and we're gonna talk about that. In just observing data, we do a lot of analytics about DHCP servers, radius servers, adjacent servers to the network. Without talking to them, we make positive assertions about how are they working and how are they functional. So yes, we do bring a system-wide view, and we do take stream data from a few third-party systems today. That's one of the things that is expanding within our AI engine, is actually streaming data from more third-party systems.
Okay, because I was thinking about the investment as well, if you wanted to get started.
Absolutely. typically people start with one building, and they see the impact right away, and then it sort of organically grows. But yeah, you're absolutely right. You don't have to fully upgrade everything day one to get to this nirvana.
Can I control which data is being sent to the cloud? Because from security perspective, I might not want to send specific LDP or radius information or attributes to the cloud for data analytics.
Oh, Peter, great question. Great question. So today, the data that's going to the cloud is just 100% metadata only, right? It has no single data packet actually ever goes to the cloud. So it is truly something that you as an IT engineer, if I had a sniffer sitting next to you and I captured the air, whatever I would capture is the data that we're capturing, right? So for the most part, from a security perspective, we have Fortune 10 companies running this, and we go through a lot of security audits and inspection around this on a daily, weekly basis. It's all just metadata. No physical data packets ever go to the cloud. Yeah.
You mentioned that you started out deploying the Mist AI solution at Juniper Network and found that only 24% of the devices were actually connecting to their wired network. And then over time, you were able to get that up to 97% or something like that? Is that what you said?
Yeah, so actually what it is, Ray, was, so basically every connection attempt, we would rank that as an attempt. And we would say, was that a successful attempt or a failed attempt? So 24% of the attempts were successful, and which is scary, 76% were not. And what was happening was there were a ton of devices that were previously connected that due to over time config change, whatever, it's that simple visibility that didn't exist. Juniper, actually, our own headquarters, we had we had SolarWinds and several other monitoring tools that never gave them this kind of visibility. And yeah, actually today it's not even 97%. They brought it to 100% over the last 9 months. This is actually, as of yesterday night, this is 100% that this is, by the way, this represents the health of 22,000 Ethernet ports in Juniper's Sunnyvale campus. That's, AI doesn't have to be complex. It's our job to distill it, make it easy to consume, but a lot of AI goes into understanding false positives, eliminating false positives. And so we'll go through this, Ray.
All right, thanks.
Yeah.
I wanted to follow up on Peter's question about security, because I don't think the data is necessarily the only thing to worry about with security. If you're collecting metadata and you're sending it through an AI engine, that means you can have an application that turns that metadata into information and perhaps connect it with other information. So what metadata are you collecting? I mean, so what do people need to be worried about what you're pulling into your system to be able to process?
Gina, great question. So metadata we collect is typically MAC addresses, IP addresses. It's that kind of metadata, and we've from day one. I mean, we actually used to run the enterprise business at a very large competitor. We had the opportunity to acquire another cloud company in there. We had a bird's eye view at what state-of-the-art security was 6 years ago, and we took that a whole another notch. I'll just give you one example, and there's a security conversation coming up as well. Like, we take our MAC address provider today. They take a MAC address, they store it in the database. We take the MAC address, we obfuscate it before we store it. So not a single MAC address. If somebody stole servers at one of our public cloud facilities, first, it's block encrypted, it's encrypted with organization-specific keys, all that good stuff. But even if all of that were shattered and they got down to it, you can't even find an actual MAC address so we've taken security to a whole another notch. Yeah. In fact, that's why the federal government was one of the investors in Mist, and this was built into our bloodstream from day one. So there's a whole conversation around it. Yeah.
But that's kind of the question I'm asking. So could the federal government actually do like they do with the cloud providers and request that information? Yes. Because they do feed that into applications that are able to track people very
well.
discreetly.
Go ahead, Bob.
Okay.
I mean, I would say, Gina, I mean, security and privacy is always an issue with every customer we deal with. It's definitely an issue with the banks, but we have banks that are now using Mist now. They're moving to the cloud. You definitely have to get over the security audits to get them to move to the cloud. The federal government is even moving to the cloud, right? DoD, they're made with FIPS. We've always known about FIPS. I don't know if you know about FedRAMP. The federal government is now basically putting FedRAMP in place, basically to move to cloud services. But it is an issue, right? GDPR, it's always an issue. Yeah. Security and privacy are like two sides of the same coin.
That's precisely the point I was asking about. It's not only about privacy and what data you're sending, but you want to have the control of what data you are sending to the cloud. So me as a customer, I want to know and I want to control which data I'm going to send to Mist. And as soon as I hear from Mist that it's leveraging metadata to redesign my topology, which I might for a specific purpose want to hide and obfuscate for a number of reasons, then that might be a bad thing. So that control of which data I am sending, that's actually a key component of trust and security in general.
I would say
it's not just it's not just the data itself, right? Because one of the other issues, again, I don't know if we'll have time to talk about it. When you create models using the data, that data becomes embedded in the data. A model is nothing but a minutia of data collection. So if you are going to use a model that's based on a certain data that's not to be used, then you need to clarify that, explainable AI, and then kosher AI to validate that model, suggesting, my data entirely came from this. So you store a snapshot for auditable purposes later. So that's even a more complicated topic.
Yeah, Andy and Peter, as much I love the passion around this, let me just say this, right? We run very, very large Fortune 100, Fortune 10 companies in general. What are the principles we've followed are follow the local compliance, follow the customer security compliance and security requirements. Happy to have this conversation another day on another security field day maybe. But in interest of time, Bob, I'm going to have you take this sort of AI primitives conversation.
Yeah. So I think the other point here is that if you look at self-driving cars, if you look at Watson playing Jeopardy, it is not one algorithm that's getting that car to drive or getting Watson to play championship level Jeopardy. The same is true with Marvis. When we started the journey, we first started with kind of what we call an SLE framework, which really allowed us to apply what we called mutual information. Now, what that allowed us to do is for one of our very largest e-commerce customers, they had a warehouse where they had a consistent problem with devices connecting to the network, right? And they never could figure it out. Once they got Marvis up and running, it was really mutual information that led us to narrow it down to they were having a particular problem with a particular barcode reading device with a particular OS. So that was the power of mutual information being applied to data. Here, what we're looking at is really temporal correlation. And the Jisheng and his team are working on what we call graph databases. Now, what this lets us do is another case we had. One of our very largest retailers basically called us up. They said, hey, you guys, your stuff is not working. Sudheer was up at midnight, about to get kicked out of this POC. It's like, how could this be? Your competitor just got through it. It turned out what had happened is someone had misconfigured a router on the other side of the network that could not pass large MTUs. So no devices on our network could actually connect. So it had nothing, Classic had nothing to do with our network, had something to do. This is where this temporal correlation graph is starting to help, right? Where we're starting to take events across the network, whether it's a configuration event on a router on the other side of the network or some health event on a router, right? Where a router goes down or a switch goes down or a DHCP server goes down. So this is really a next framework that's going to let us get to that next level of championship Jeopardy, is basically starting to correlate user experience events with some other event in the network, right? And this is what we call temporal correlation.
Yeah, and so again, where this leads to is when we are able to stitch a user's experience across wired, wireless, WAN, that's when magic happens, right? So Juniper Mist, we are sort of in a very unique place where we have one cloud that mans the wired wireless WAN assurance experience. And so once you stream data like this, and you're able to ask the question, why is somebody having a bad Teams experience or Zoom experience or Skype experience or whatever, we're looking at the user's experience on the wireless link, on the switch, on the WAN link, up into the cloud. And so being able to put that entire client to cloud perspective is very, very, very unique to us. You take siloed SD-WAN players, that's all they do. If you take, traditional companies, they have different systems manning all of this. So we feel really good. This is what we call the client to cloud experience, and bringing AI all the way from the user, which we're going to talk about, the Marvis SDK, but all the way from the user into the cloud. This is an example of that. Now, so Jisheng, maybe let's talk a little bit about, a lot of this results into finding actionable insight on the network. So Jisheng, I'll turn it over to you.
Right, yeah. So I will quickly go through a couple of, like Bob said, we really have, it's not just one model. It's really, a mix of the models, heuristics, and it's a very complex system. I just pick one example, anomaly detection. Just because I think, as you know, anomaly detection is probably the most widely applicable ML problem that almost every product needs to address, right? It's the same for us. We have been spending over 4 years of time continuously tuning and improving our homegrown anomaly detection model, and finally reached very high accuracy with this neural network model called ASTM, long short-term memory. And by training a multivariant STM model, we can really capture both the temporal and the spatial correlation over all these various user-centric features, like Sudheer demo. It's multivariant because we have so many of the features and the parameters we need to track. And this actually guarantees a very high efficacy of this anomaly detection model, because we only detected the user impacting network issues. So they are on the productive, ML is not just about model, right? It's all about this productization. Rather than other vendors which just train one model for all of one cost model for all their customers or for one industry sector, we are actually baselining and training one neural network model for each site. So it's not one model for each customer, so it's one model for each customer, each site. Why? Just as you know, Walmart has thousands of stores. The store in Cupertino may have different characteristics than the store in Mountain View. So as a result, you can see we're really training and servicing over 10,000 neural network models simultaneously in Marvis. This really showcases the power of a cloud-native infrastructure.
So Jisheng, you mentioned that you're training separate models for each customer site for anomaly detection?
Yes, because it's a
how many customer sites you guys got? You must have thousands of customer sites, maybe millions. I don't know. It's phenomenal, right?
So far, I think we have tens of thousands.
10K sites. Yeah. So you have 10K separate model training activities going on and inferencing activities going on.
This is really the power. This is the main differentiation of choosing a cloud-native infrastructure. This is
impressive. Thank you.
Yeah. So we're not just talking about models. At the end, all of the training a neural network model, as some of you may know, it's very low bar work at this moment. 10, 20 lines of the Python code on top of TensorFlow. But servicing the neural network at this scale and achieve very high accuracy, that's really the top level problem we solve for the industry here. I don't think any vendor can even close to this here and this accuracy.
Anomaly detection is a double-edged sword, right? There's the intelligence you can get from your own infrastructure, but then there's also intelligence you can get from other folks as well. Can you talk about how you're bringing both of those together, if assuming you are, but are you bringing both of those together? And if so, how? Because, for me as a customer, understanding what would be an anomaly within my infrastructure is one thing, and that's incredibly valuable. What would be even more valuable is if something is seen in another customer that I can then benefit from.
Yeah, that's a very good question. So we are doing something like the transfer learning concept in this anomaly detection. It's not even not talking about the cross customer. Just think of, as I mentioned, different sites. Like different stores, even for the same customer, may have a slight different behavior. The store setup, especially we care about our client. Clients certainly are different, right? So when you bring up a new store, think of that. Rather than, because anomaly detection need a baseline, we use 30 days of the data to train the baseline. But before you start, we don't have any data. What we do actually is we take the model trained from other sites of the same customer, which may have similar behavior, to start with. So it's not a cold start, it's a warm start. Then based on the continuous data we collect from this store, we will add the customization into the model. So this is a transfer learning concept. This is the exact reason why we have to train one model for each site. Because if you put all this site behavior together, the model is going to be too coarse. It's really a good balance of the granularity and also the sensitivity. So this
right. No, I get that where something that might be an anomaly for me might not be an anomaly for Ray, for example, in his infrastructure. Right. But that's, I think, where the fine tuning comes in, and the intelligence could really kind of benefit both of us.
Yeah.
I think the answer, Tim, is yes, we use global data for transfer learning, but ultimately each network is unique. Ultimately, you have to get down to that site. One site, site in India is not going to be the same as the site in the US. But yes, the transfer learning lets you leverage the power of the global data. And then you basically want to train models on things. The other thing I wanted to point out is, when Sudheer and I left Cisco, the thesis of Mist was that there was a fundamental architectural change between cloud and AI, right? We had just got done acquiring Meraki, and I could tell that if you want to do AI, you basically have to have a real-time cloud infrastructure to actually get this to work right. Right. And that's why I think you're seeing some of our competitors starting to struggle here, right? Ultimately, you have to have, it's really a blank sheet of paper problem. You got to build the right infrastructure to handle all the data that's coming in, right? 10,000, you think doing 10,000 models is difficult, but not if you have the right architecture.
Right. Exactly. I think that, like Bob said, people saying, oh, I will train one model, which is good for, this like similar customer. Just ask the question, whether it's because of your limitation of your capability of training really the best granular model. So, but anyway, so the other challenge, anomaly detection, we pick this because it's so common across the, different industries. Another common challenge of anomaly detection is this difference between statistical anomaly and business anomaly, which user really cares about. This probably is also to the question Tim asked about. So for example, you cannot wake up the IT team at 2 a.m. in the morning just because your neural network model found some deviation. At the end, you have to turn each anomaly into actions. So here, like Bob talked before, for each anomaly we detect, before we send alerts to the user, we actually use mutual information to find really the relevance of different network attributes to really find the root cause of this anomaly. Like as shown in this example, you can see the Windows device. This is what Bob talked about, that e-commerce customer. So the Windows device actually is highly associated with the failure of this anomaly. So what happened there is actually pushed the certificate update to all of the Windows devices for that site, but forget to enable that or before enabling that on the Redis server. So it ended up suddenly all of the Windows devices start failing, which triggers the anomaly. So you can see the key here is not just to send the model result, to the user, which sometimes is noisy or overwhelming. The key is to really find the root cause behind each of the anomaly to really turn them into actions.
So the model per site and update is not all that different than the edge concept, right? From my earlier life, working with edge devices. Every edge is considered as isolation, and then the model can be customized for that. When you do that, the issues, what they face in that is The first one is once you continue to customize that model per specific edge, the model starts to deviate from the norm. How do you handle that model runaway, right? That's one issue. Second one is at what time when you infer things at the edge, the model is not standard, which is a deviated model, what time you think that you had to update call home and update the central model. But more importantly, when do you decide to update the centralized model and then push it out to all the edges?
So these are very good questions. Let me answer them one by one. First, it's not the model is actually the inference is done in the cloud. So we don't push the model so far. We don't push the model down to each of the edge devices. The inference is done in the cloud. So all of this training, there's no like central model. As I mentioned, each site has its own model. So this model updated every day with last 30 days of the sliding window of the data. So then come back to a model, when the model deviates, that's a very good question. When you use the 30 days, the behavior can change. The reason we use sliding windows to try to not dramatically change the model for each site. But still, sometimes I can tell you, when you really go to the productization, there's a lot of problems. The model can change, not because the behavior change, sometimes because of your data pipeline issue, right? So you may drop some data. So we end up, this is really the beauty of this, multi-tenant cloud environment. So we actually, every day after we retrain the model for each site, we actually check the deviation for each site. If we suddenly observe a big change across all Mist customers, since their behavior, what does that mean? That probably is not the customer behavior change, it's something changing in our cloud. So we actually use this cross-customer validation correlation to really detect these days. We even detected the bias introduced from our cloud pipelines.
How often you do that? Is it a daily basis, minute by minute basis?
It's a daily basis. Every day it's retrained, then it's correlated across the Mist universe. And it actually, there's also validation stage. It's not saying we train and we deploy, because there's other kind of issues can happen. We have to train, there's self-validation. You check each of the site model, how much deviation, and you check the global. And unless they pass the criteria, we're not going to actually, this is automated. Training, validation, deployment, and inference. When the model is deployed, saved in S3, like for example, for AWS, the next minute it will be picked up for the incoming data anomaly detection. So
the validation is real time, but the updation is based on the needs. Okay, got it. Okay.
Exactly. So all of this is totally automated. We don't do any manual tuning, all of these things. And this is running at that 10,000 neural network models.
So very quickly, what does this mean to our customers, right? So as I said, one of our very large customers, they deploy 2,000 APs every night. And as they're deploying APs, as they have APs that are deployed, if they need to go and figure out, is all my config correct? Is all my, systems properly set up? These are 3 examples. I know the video is probably not legible, but 3 examples very quickly is, if you deploy an AP and the wireless user VLAN is missing there, we can detect that, we can find out, we can alert them. Again, from a user experience perspective, they'll say, hey, I walked under that AP, my Wi-Fi dropped. Reality is nothing to do with Wi-Fi, right? Same thing, if there are devices that were previously connected and are now, for whatever reason, unconnected, or if I'm seeing lots of failures and a spike of failures suddenly on a Radius server or a DHCP server, without speaking to those servers, very high efficacy. Today, when we call this Marvis actions, by the way, for those of you who are new to Mist, and when a Marvis actions webhooks alert or a streaming alert happens, our customers don't even bring that to network engineering. They directly send it to operations, hey, go take care of it. They have that level of high efficacy confidence. When we do anomaly detection, take it to the bank, right? So this has been very, very helpful in some very, very large networks, real examples, real feedback. Now, so the next piece here, if you just to recalibrate on our journey, we talked about data, we talked about AI primitives, and we talked about the toolbox, the AI toolbox. And we're going to talk about more tools in the toolbox. But the fourth vector there is this notion of a virtual network assistant. And so, Bob, you've been our vision and inspiration for this. I'll have you lead this.
Yeah, thanks, Sudheer. So if you look at the 20-year, on the industry and the journey we've been on, 20 years ago, it was all about CLIs, right? Everyone was managing these boxes by CLIs. 20 years ago, we took dashboards, right? And we basically took the IT department and the industry and said, let's move away from our CLIs. Let's start managing these networks by dashboards. And then we went to APIs. Then we just said, hey guys, everyone needs to learn Python. And this is what Sudheer said. This really took the deployment scale up, right? People who were deploying, 1 store a night to now deploy 50 stores a night. And that was really around basically cloud API. We're really moving into the next era of conversational AI, right? And this is really going to be the era of making it easier for our IT teams to actually get to the data they need quicker, right? And this is where the conversational interface is going to become the new standard for actually interacting with your network and getting data out of your network. And it's got 2 components to it. One is actually being able to learn to trust your AI assistant. So we talked about earlier, that conversational interface is going to be the key point of getting to know Marvis. How do I get to trust Marvis? Marvis, how did you get to your answer? I think several of you pointed that. You want to know how someone, whether it's a human or an assistant, you want to know if you can trust that answer. You want to see the homework behind it. And plus, you want to be able to start giving your AI assistant feedback. Hey, Marvis, you got the wrong answer, right? And I want you to get better. So this is where I call the new era of conversational interface. As a fun thing, I've seen some of our competitors poke fun at this here, but this is really where we're headed.
Some of our competitors said, "Oh, NLP, that's terrible," blah blah blah, and you're going to see them talk about it. So, but Jisheng, I'll have you take this away.
Yeah, thank you, Sudheer. And this is the high-level architecture of the Marvis conversation interface, right? So there are like 3 things I want to quickly highlight here. From the left to the right, first is this unified interface. As Bob mentioned, this is going to be the single interface to satisfy all different requests for the day-to-day network operation. No matter you want to troubleshoot something, you want to even configure something, even open a ticket, it will be all done through this neutral language-based, NLP-based interface. The second is this NLU engine. As you know, one challenge of developing a chatbot is the feedback. Like Bob said, you want to collect the feedback continuously involved. But people tend to lazy to give the feedback. All people only give the bias feedback when they are dissatisfied. So with this new interface, we actually have a built-in ML-based sentiment tagging engine. You don't have to manually tell us every time whether you're happy or not. Marvis knows that while talking with the user, and will continuously learn and improve. Last but not least, this interface, rather than some general purpose like network kind of chatbot you probably see before or later, this one is fully empowered by this Marvis intelligence we have learned over time for each customer, like your baselining, like anomaly detection, knowledge graph, etc. So this is really differentiate us from other, general purpose of the chatbot in the industry. Yeah, next, I'm going to quickly talk about this. I don't want to spend too much time on this. This NLU engine still is the core of any of the chatbot. How smart you can understand the user intent and the questions. Here we use the transfer learning. I talked a little bit about anomaly detection, but this is another application of that. As you may know, transfer learning is really the foundational ML technology for almost all of the groundbreaking advancement in text and voice recognition these days. The most famous example is the GPT-3 released by OpenAI, a few months back, which got a lot of the attention in the NLP world. So similarly, while we do Marvis conversational interface, we are leveraging a state-of-the-art NLU engine, which is pre-trained with over 10 million articles. And this is also the same engine used by Google Home and Amazon Alexa. What it really helps us is a big boost of the Marvis interface in terms of the understanding the general intent, entity resolution, etc. By standing on the shoulder of this NLU engine, what we need to do is to add this network-specific dialogues, Marvis has learned and accumulated in the last couple of years. So the key concept here is like we're not reinventing the wheel for everything we do. In this case, we leverage the state-of-the-art NLA engine from other industries, some consumer industries, but bring the best user experience for the network customers.
And so I think just as a quick demo, what are we talking about here? What we're really talking about is, I think today there is more and more and more data as you're managing these networks at a global scale, right? So more dashboards and more data and more of that is not the answer. We really believe that an ability to interact with Marvis, ask simple, seamless questions, get actionable real-time insight is truly, AI-assisted insight is truly the future, right? So whether I want to take actions with the chatbot, whether I want to troubleshoot you with the chatbot, whether I want to be able to say, hey, what's wrong with the network, and just get down to work. We really believe this is the future. We're investing quite a bit into the conversational interface here, and this is sort of just the beginnings of this, right? So this is sort of our true north for us. Is the dashboards will exist. The data will exist. You can always look at all of this data, but ultimately we think networks can be operated using sort of this conversational interface.
So I see that you have building a complete conversational interface. Is that a standalone interface just for you, or do you have any plans to interface with the other existing conversational interfaces, namely Alexa and others?
So we are, we today via API integrate with Siri and Alexa and other systems. Our SEs and customers have written integrations, Andy, already. This is you interacting directly with our AI engine, right? Speaking to Marvis. So this is a standalone, built-in, system-wide, across wired wireless WAN client-to-cloud interface. So one interface across your entire network, but specific to your network.
Yeah, Tim, to answer your question there, I think this is, we use some of the we use some of the open source, chatbot or conversational interface framework. Then we build our knowledge and this intent, entity, all of these things on the top. Actually, that framework comes with all of these APIs directly to Slack, to Alexa, all of this. As long as we build the core there, it can be very easily integrated with other of the tools.